Hi, welcome to another Unity from Scratch mobile development tutorial. In this tutorial, I'll show you how to use the swipe trail that we've been developing in the last few tutorials to recreate a very popular game which you may have heard of called Fruit Ninja. Now, what I've got in this scene to begin with, you'll see that I've already got my model. So I have an apple that I'll be using, and there's a half for that apple and there's also a quarter for that apple. If you want to get these models, you can get it from my website, holistic3d.com/resources. And this model I believe I got from Turbo Squid many years ago. Anyway, I've kept it and I've put it on my website so that you can use it too. And it comes with the material as well. So just drag and drop that into your project, and you might need to also put the material onto it if they don't come with it already. Right, so to begin with, I'm going to take these out of the scene in a moment, but what I've got in this scene, which is a 3D scene with a main camera, it's set to perspective, and there's nothing special about that. I've added a directional light because I didn't get one when I first came in, and I just rotated it around a bit. But I've also put unlit textures on these apples as well, because when the lighting was on I didn't quite like the way it looked, so I guess it's a bit superfluous having a light in there with unlit textures. Anyway, that's the way it is. Now I've added a swipe manager, which we looked at a couple of tutorials ago, just for doing a really simple swipe on the screen, and it has attached to it a trail renderer. So this is an empty game object with just a trail renderer added. Now the specific settings that you'll need for this particular swipe, I've got the time as 0.2, a start width of 1, and an end width of 0.1. I've also added in some colours, and I've just used the sort of rainbow colours there. The material that I've put on it is white material that I created, and that particular material itself is set to the shader of FX Flare, and it just has a white texture on it. So when I run this, you'll see the effects of that trail. So it doesn't last for very long, but I can just swipe across the screen. And remember, this will work for a mobile and also our desktop machines, this particular code. So it's the same code on this swipe manager that we've used before, and I'll just open that up and show it to you again. It's really short. So it's testing that if there's a touch on the screen and that touch phase is in the moved, so your finger is moving, or if the left mouse button is down. This is what makes it work for both cases. Now what I do then is I do a ray cast onto a plane, and that plane is in the camera's viewing volume at the same distance as that swipe manager. So you have to make sure, if I can just pull up my camera, the camera's viewing volume that you can see here looks like a pyramid, and the swipe manager itself is at that position there. So it's at 0, 0, 0, and the camera by default is always at -10 in the Z, which will make this swipe manager be inside that viewing volume there. And that's where that plane will get created, that we are then determining the mouse location or the finger touch location on that particular plane, and that's where we are drawing the swipe trail. Now this is all explained a couple of tutorials ago in this playlist, so I won't go into a lot of depth. Next we need to make some prefabs out of each of these pieces of apple. First of all, let's select the entire whole apple, which is called single apple. I'm going to also tag each of these objects because it might come in handy later on in the code. So while we're there, let's just go and add a tag, and I've already added one for the quarter before, but I'm going to put in let's put whole, and I'll also add one for half. Okay, so the quarter apple I'll tag as quarter, The half apple I'll tag as half, and the single apple I'll tag as whole. Now, interestingly, the single and the half apple are actually whole meshes within themselves. The quarter apple seems to have a lot of stuff going on underneath it, which will kind of make it probably a little bit difficult later on as far as putting rigid bodies and things on there, but we'll see how we go. So let's start with the single apple. First of all, let's add a, sphere collider to it. We need the sphere collider so that we can register when it has been hit. And we also want the apple to fall with gravity. So let's add in a rigid body as well. Now you want to do that with the half apple. Sphere probably won't be the best thing, so let's just put a box collider around it, and let's add a rigid body to that. And then for this quarter apple is where things might get interesting. Let's add a box collider. Now, because it didn't have the original mesh to actually reference, you can see that in this case, if I can zoom in closer, is that the box collider for this particular quarter apple is sort of way off. So we want to move it around a bit and resize it. So just play around with that box collider until you get it to about the right size and in the right place. Once the apple is in quarters, then you probably aren't too concerned about this actual collider because you're not going to be swiping over the top to break it up anymore. But let's just get something reasonable so that it will collide. Oops. Okay. Alright, that's not too bad. Now with that collider on there, let's also add a rigid body. And when we press play, all of these objects should just fall from gravity. Okay, great. So that's all working. Now we'll make prefabs out of all of them. So grab the single apple, drag and drop that into your asset. Half apple, drag and drop that into your assets. And quarter apple, drag and drop that into your assets as well, so that you now have the prefabs ready to work with. Now it's time to update the swipe trail code so that we can detect a swipe over one of these objects. Right, so I've already modified this code, and what it's become is a mixture of the swiping action code and also the code from a few tutorials ago in this playlist where we started to pick 3D objects up with the mouse and move them around. Now, first of all, right at the top of the file, I've added in 3 public variables that we can pass in our prefabs for the whole apple, the half apple, and the quarter apple. And I just realized I spelled that wrong. And after that, you've also got a variable gobj, which is going to point to the current game object that we have swiped over. Now, in order to determine what we've hit with the mouse, we have to do a ray cast into the environment. So we're using this generate mouse ray function that we developed a few tutorials ago. So I won't go into all the ins and outs of this, except that it will pass a ray into the game world, and this will then be used to determine whether we've hit something with the mouse or a finger touch, and it will work in both orthographic and perspective views. Okay, so the update function has changed just a little bit from before. I've added in this little bit of code here where we're using that generate mouse ray to project a ray from the mouse position, which will also work for a touch position, and then doing a physics ray cast to see whether we hit something in the environment. And if we do, we set the object that we've hit to this gobj variable. It's at this point we're going to determine what exactly we've hit and remove it from the game world and replace it with whatever it needs to be replaced with. So if it's a whole apple, then we're going to remove the whole apple mesh and replace it with the two halves. All right, so let's save that. Switch back into Unity and go to your swipe manager and put your prefabs into these exposed ones here. So we've got our single apple, our half apple, and our quarter apple. Back in the code, we then, inside of the physics raycast, after we've grabbed hold of the object that we've swiped over, is we then test for what the tag of that object is. Now, if it's whole, in this case, we've hit a whole apple. And at that point, we're going to use the half apple prefab to instantiate two copies, so two halves, H1 and H2. And after we've done that, we're then going to destroy the whole apple. So this will replace the whole apple with two halves, because the halves will be at the position which is of the existing whole apple and with the same rotation. So let's just have a look how that's going to play out. If we save that, let's just remove our quarter and half ones out of the scene. Let's leave our whole apple there and we'll swipe at that because it's already in the scene. So play, swipe, and we get two halves. Now it happens quite quickly. What you don't see is the actual rotation of those halves when they first come out. So just to check what the default rotation will be, because it's setting those half apples to be at the same rotation as a single apple. So if we go to this single apple and let's just set it to be 0, 0, 0, it's going to look like that. And if we add in our half apple here, and then we set its rotations to 0, 0, 0, it's going to look like that. So it's actually rotated fairly differently to this particular apple itself. And if you are to set this to the rotation of that, thinking that this is currently 0, if you set this to 0, this is what you're going to get. So they're totally unaligned, and you can, I guess, allow for that in the actual code. Now what you'll want to do is to align the new prefab to the existing prefab and then work out what the extra rotation is that you need to perform. So to do it accurately, set the initial one to 0, 0, 0, which I've done for this single apple, and also make sure you've got your half set to 0, 0, 0. Now this half needs to sit, well, it could sit multiple ways, because it could cut the apple this way or it could cut the apple that way. I'll cut the apple this way, so that this half here needs to be rotated around to sit on this top half. So grab hold of your rotation axes and then rotate the apple half until it's in the same alignment that you want it, which is pretty much like that. We're talking about rotation, not position. So that's the rotation it would have to do to sit on top of there. Now over in the inspector, what you need to do is have a look at the rotation and just clean these up. Okay, so this is 89, so it's 90, and this would be minus 180, and then this will be minus 90, and that will then position it for you. Now if you record these values here, you can then use them in your code to rotate that half back around to fit with the top of the apple. Now you do the same thing again and rotate it for the bottom half, which would look like this, and then again clean up these angles here so that they're on the 90 degree, minus 270 that would be, and this would be minus 180. Now the combination of these X, Y, and Z rotations, you can get multiple different rotations that you would use to get actually the same outcome depending on how you've rotated it. But anyway, just make sure that you note down what these rotations are that you need, then come back in your code. And what you need to do is put those rotation values into this function here. Okay, so after we've created our half and we've rotated it to be relative to the actual whole apple, we then multiply that rotation by the little extra rotation that we just worked out. Now, the rotations I just worked out and showed you are slightly different to ones I worked out earlier, but they end up the same way. So whatever the X, Y, and Z is in the inspector for the half when it's aligned, it goes inside of here, and this will be added onto it. Right, so let's just go back into our code, into Unity, and what I'm going to do is go to our apple half and just make sure I've still got the gravity and the collider turned off, and then just run this and click on the whole apple. Okay, now you can see what's happened. It's created the two halves and they're exactly facing the right direction. They're just not aligned very well. So let's see, we've got this top apple, I think it must be, needs to come up like that. So not only are we adding in a rotation after we instantiate that half apple, we want to move it up as well, just to get a little bit of alignment. So we're going to move that up a bit in the code. Now, as it works out, if you play around with the position of those halves, you'll find that if you move the first half of the apple by -5 in the z-axis, its z-axis, then it will align pretty close to having a full apple made of two halves. So let's just go back and run, and let's click on that full apple again, and now you can see there's the two halves that have eventuated. They're pretty close together and they're nicely rotated and aligned. Right, so the next task is to do the same thing with half an apple and the quarters. So let's just remove the single apple. Here's our half apple. Just check that it's still at 0 rotation, which it's not. So just put it at 0, 0, 0. And let's bring in the quarter apple and have a look at what it looks like. Make sure it's at 0, 0, 0 for its rotation as well. And of course it wouldn't be aligned. Ideally, if you're doing this and you're making your own fruit objects or objects that you're going to split in half, then you're going to model them all with the same axes facing in the same direction with the same position. We're using someone else's model here, so we don't really have that luxury, and more often than not when you're using someone else's assets, it's always good to know how to do this anyway. Right, so this is our quarter apple, and in order to align it like that, let's just get our rotation. First we want to rotate it like, whoops, wrong one, like that, and then rotate it like that, which will give us this top half here. Now that rotation there will be -90, that's practically 0, and then -90. So it's -90, 0, -90. Right, so in the code, let's grab all of this, copy it and paste it down the bottom here with an else. So we're now dealing with a half where we're instantiating the quart prefab for these two halves of the half. And for the first half rotation, I'll just comment out this translation, we don't know if we'll need that yet, and it was -90, 0, -90 for that first half. Right, save that, and let's just switch back here and we'll do the other rotation while we're here. So for that bottom half, it's going to rotate it like that, which will eventually clean up to 0, -180, 90. So we'll use those values. 0, minus 180, and 90. Right, let's save that and let's go back into here. We will also grab the quarter apple and turn off its gravity and box collider. And just before we run it, let's check that the half apple has its box collider turned on, otherwise it won't register us swiping on it. Press play, swipe it, and it splits in half. Okay, so that's not too bad. Now, yes, you could muck around with your translation and then align that up really nicely if you want to. I'm just going to leave it divided like that so we can just get on with this tutorial. Right, so now that all of those values are lined up, what you'll need to do is go back through your prefabs for your single apple and make sure you've got your gravity, your sphere collider on for all of the objects. And then you can remove the prefabs from there. Okay, so let's test it with just a single apple, and we'll put that in the scene. And just move it into view. Press play. Okay, now what you'll see there is that the swipe actually cut it into 4. What it did is it cut it into half, but then it also registered cutting it into quarters straight away. So to fix that, we need to add a little bit of a cooldown period on our swipe trail so that we can't do any more cutting for a certain amount of time. It's a similar thing that you might put on weapons in other games, that they have a cooldown before they can be used again. Otherwise, you're kind of using them over and over again too fast. And in this case, you're doing it so fast that you're not getting a chance to sort of swipe it, let it go to half, and then swipe it, let it go to quarters. Right, so we come back into our code. I'm just going to remove this translation because I'm not using it for those quarters anyway. And in the ray cast here, we're actually going to do a little test and test for swipe cooldown. And we'll use swipe cooldown as a variable, which we'll set right at the top of our program. We'll make it a bool value and set it to equal true, so that the first time you swipe, it will actually cut something. Now, once you've swiped the first time, you then say swipe cooldown equals false. Save that. Now let's go back into Unity and just have a look what happens. The first time you swipe, it will actually cut, but the second time nothing will happen because you won't have cooled down yet. So if we press play, we can swipe into halves, but then we can't swipe anymore. So that cooldown is working. So other than setting it to false here, at some point we need to set it back to true, and we can do that in its own function. So up just above update, I'm going to add in a function called void cooldown, and inside that function we're going to set swipe cooldown back to true, and this function itself is going to be invoked after a certain amount of time. So we can use invoke, which will allow us to call a function at so many seconds down the track. So this function is called cooldown. The function name needs to be in quotes, and then the amount of time you want to leave before you can actually do another raycast, or at least do another swipe. I'm going to put 1 second. For this type of game, it's probably a long time, 1 second, but you'll actually be able to see it in action. Swipe cooldown will be set to false, and then the invoke cooldown will be called, but swipe cooldown won't get set back to true until after a second. So let's just try this out. So I should be able to swipe it, but nothing's going to happen for a second, and you saw that right there. Okay, so we'll leave it there for part 1. In the next part, I'll show you how to create a spawner that will shoot out these apples that you can then cut in half, and how we can add a little bit of physics onto these to make it look a little bit more interesting as they're being instantiated.